Hello everyone, I hope you're all doing fantastic. In this particular video, we're going to be taking a peek at VPC peer switches, virtual port channels, and we're going to be using Nexus Dashboard Fabric Controller, or the NDFC, to manage and configure the VPCs on an EVPN environment using both Nexus 9kV switches and Catalyst 8kV routers. So let's look at the topology that we have in store. So in the topology, we're going to be focused in on data center 1, which is on the right hand side. We have a very simple fabric made up of a spine up top and 2 leaf switches, which you can see have back-to-back connections between them over E16 and E17. So they're going to be our VPC pair. And then we have 2 Cisco 8kV routers, which the one on the left has dual connections, 1 to each leaf, and same thing on the right, dual connections to each leaf. So let's hop over to the NDFC. I have a fabric that's just been pre-built. However, there's no switches in it. So let's go ahead and just add the switches. So we'll go ahead and discover the switches. Okay, so there's our spine and 2 leaf switches. We will go ahead and add them. This could take 1 minute to 3 minutes, so I'm just going to stop the recording while the progress continues here. Okay, so we can see all 3 switches have been added, so I'm going to close this. I'm going to set their respective roles. In the topology that we're working with, the spine is actually going to be a border gateway spine. Border gateway spine. And then the 2 switches in this particular case are actually border leaf switches. So I will set those accordingly. And then we will go ahead and recalculate and deploy. Just to show you back on the topology. So this spine is connected to the ISN, which makes it a border gateway spine. It's got the leaf switches below it. These leaf switches have connections to the WAN, which make them border leaf switches. So we'll stick to the topology here. But for the VPC functionality, it does not impact us. So we should see 335 lines per, so we're going to go ahead and deploy that. While this is deploying, I'm going to just pause the recording. Okay, so we can see our deployment finished. It was successful, so I'm going to close out here. And literally, this is how easy Cisco made this with the NDFC. So now that our switches are discovered and they have the appropriate role configured, what we need to do for the VPC pair is if we select one of the leaf switches, so in my case I'll select leaf 01, I will go to Actions and I will go to VPC Pairing. When I click VPC Pairing, it makes a recommendation. You can see recommendation is true for DC1 leaf 02, so it's recommended that we use leaf 02 as our VPC pair. And the reason is because it says they are connected and have the same role. So that is correct. I am going to save that. It says please perform a recalculate and deploy. Okay. And now we can see that under the VPC pair column, we have the appropriate switches highlighted there. And we can see that there's a pending config change. So let's go ahead and take a peek at that. We're going to recalculate and deploy. So it looks like it's going to push 50 lines to each switch. We can see it activates the VPC feature. It does the VPC domain, does the peer switch, peer gateway. It does everything it needs to do, configures the port channel, puts the 2 member interfaces in the port channel, and then it looks like it's using the loopback to essentially do in OSPF peering for underlay purposes. So that's awesome. So we're going to go ahead and deploy all. Once again, I'm going to just pause the recording while this is deploying. Alright, so that literally only took about 15 seconds, so looks like both were successful, so we'll close out here. And at this point, we should have 2 leaf switches that are in a VPC pair and happy. Now, what I did was, if we go back to the topology, so let's take a peek at this first Cisco router on the left. So he has a link going to leaf 1 and a link going to leaf 2. Let's go ahead and get connected to him. Let's get rid of the spine. Here is that router. So he will eventually have the IP address of 10.1.101.11, but we will do that here in a second. If we show Ether channel summary, I have pre-configured the port channel. So you can see that gig 1 and gig 2 are in fact bundled in port channel 1, but they are currently suspended and down because we did not configure them on the NDFC yet. So if we show IP interface brief, I've also pre-staged the IP address as a sub interface off of that port channel. So for this particular example, we're going to make these links trunks, and we're going to basically have a sub interface of 2301, which is the network for 10.1.101, or it will be, excuse me. So let's go ahead and, since this is a new fabric, I just have to create a VRF real quick. It's tenant 1, propose VLAN. So let's create that. Let's go to networks. One thing I want to point out here is on the topology, since these are border leaf switches in this particular case, what we need to be concerned about is this checkbox here. It says enable the L3 gateway on border and border gateway. If we don't check this box, the NDFC will not configure the default gateway for this particular network. So it's important that we select this box. So I'm going to go ahead and check that off. And I'm going to create this. This is the first network. And then I need to create the second one next because it should grab the next VLAN ID, which is 2301, which based on our pre-configured router, that's what we have. So this is going to be the network that we actually attach to the router. So you can see when I hit propose, it takes the next one, which is 2301. I'm lowering the MTU because I'm using Nexus 9 kVs, and I don't want to have to reboot them to enable the jumbo frame TCAM allocation. So I check that box once again. Let me go ahead and say create. So that should create our second network. Now, as far as the interfaces go, everything should be in. So we got 4 and 5, right? 4 and 5 are right now, they're just all default, which is looks like they're set for routed host. So we'll come back to that in a second. Let's go ahead and recalculate and deploy. All right, so doesn't need anything yet. All right, let's go back to so we need to go to interfaces and we need to say create an interface. In this particular case, we're going to create a virtual port channel. So it's going to ask you what is the virtual or the VPC pair that you want to configure this on. It's going to be the only one we have, which is the one we just created, which is the leaf 1, leaf 2. It's going to choose a VPC ID for us, which is fine. This policy is what we need to change based on our topology. So in this particular example, if we go back to the topology, we're configuring the first AKV, which we had already said was going to be trunks. So what we're going to do is we're going to leave that as VPC trunk host because that's what we want. Now for this part, they give you this checkbox which says enable config mirroring. So if you check this box, they're assuming that the interfaces that you have between the leaf switches are the same. So if we go back to the topology, gig 1 on the router goes to E15 of leaf 1, and gig 2 goes to E15 on leaf 02. So in my case, I can use the port mirroring because it's the same interface on both leaf switches. So I can check that box, and I just have to put E15. And you can see it kind of just trickles down to the second member interface for me, and it just prevents me from making a mistake. I'll just turn BPD guard to false. I'll make the MTU default as well. And right now we're just going to say trunk allowed none. We'll worry about that in a second. So I'm going to hit save. And I'm going to deploy this change. Looks like it wants 14. It's expecting 14 lines, which you can see it takes my interface 1.5, basically puts it in the channel group 1. It is a switch port mode trunk, so that looks good to me. And then under the port channel, it adds it to VPC 1. So let's go ahead and deploy. Let's come over to the router while that's happening and see if we see any action on the router itself. So we can see that it looks like we're getting status messages saying that the ports are being added to the port channel, which is a great sign. We can see that there was success in the background from the NDFC, and we now see that port channel 1 has changed state to up. So if we show Ether channel summary on our router, we can now see that gig 1 is bundled, and same with gig 2. Now we shouldn't be able to ping anything or do anything because we still have to attach that network. So I have a simple default route that says all my traffic should go to the gateway 10.1.1.0.1.1, but like I said, we should not be able to ping that quite yet because we didn't attach any networks via the NDFC. So let's go ahead and do that. So we can close this. If we go back to networks, all right, we want to attach the 10.1.1.1.1. So if we go ahead and double click him, we're going to go to network attachments, all right. We want to attach him to leaf 1 and leaf 2. So we'll say edit. We will attach, and we're going to attach to the port channel 1. Okay. So once we hit save here, we get a pending change saying that, okay, we're going to attach that network to that port channel. So let's go ahead and close out of networks, and let's do a recalculate and deploy at the fabric level. Okay, so it generates our code, which looks like 66 lines of config. So let's just take a peek. So we can see now that under the port channel, it's allowing VLAN 2301. So it's adding it to that trunk, which is what we want to do. Okay, we can also see down here under the interface VLAN 2301, it's now creating that gateway as an Anycast gateway. So this is hopefully going to fix that ping. So let's go ahead and deploy this. While that's deploying, I'll come back to the router and I'll do the same ping, let's just say 100 times. And look at that. So about the same time as the progress bars behind the terminal went to the far right, we got our pings back. So now we can ping our default gateway from the first Catalyst AKV router. So that is a great sign. So at this point, let's look at the second router. So the second router will have the address of 10.1.101.12, but you can see there's no sub interface under the port channel. So in this particular example, we want to try to make these ports access ports and only have 10.1.101 essentially assigned to those interfaces. So let's go ahead and see what that looks like. So if we come back to interfaces, in this case we want to, once again, we want to create an interface. We want to create a virtual port channel. We're going to select the pair, right? However, in this case, for the policy, we're going to do an access host as opposed to the trunk host. So we'll select that. And then we can do the mirror again. So let's go back to the topology. So in this case, it's port 4 on both leaf switches. So E14, we'll stick with active, we'll turn BPD guard to false, and we'll lower our MTU to 1500. Alright, so that looks good. Let's go ahead and save that. Let's go ahead and hit deploy and see what we see. So it's expecting 12 lines. So we can see that in this case, it's changing it to an access port. It's putting it in channel group 2. Alright. So that looks good. So let's go ahead and deploy that. So if we go back to the router, we should see the similar route. So we have a basic default route going to 10.1.101.1. We can see that the port channel is now changed state to up. All right, let's come over to networks, and I want to take a peek here. So we need to attach 2301 to port channel 2 as well. So we're going to highlight port channel 2. You can see the difference, right? It's access as opposed to trunk. So let's go ahead and save that. We have a pending change. We'll close out of networks. We'll come to the fabric level and we'll do a recalculate and deploy. So what I would expect to see here is essentially switch port access VLAN 2301, which is what we see. So let's go ahead and push that. We should see that they are bundled in a port channel, so that is good. And let's go ahead and try to ping our default gateway, so that is good. Okay, perfect. So at this point, 1.1. So the Catalyst AK1 has the sub interface with the port channels that are, or the port channel that's made up of trunk interfaces. It can ping its default gateway. The Catalyst 02 is built as access ports where the IP address is just on the raw port channel interface, and it can ping its default gateway. So let's go ahead and try to ping each other, which we certainly appear to be able to do. Alright, so that, my friends, is how you configure Nexus VPC pairs with the NDFC, and also demonstrated how we configure VPCs down to end hosts 2 different ways, one with trunk ports, one with access ports. So hopefully you got something out of that, and until next time, thank you and take care.